Example 2. Prove the following. The sine of theta plus 60 minus the cosine of theta plus 30 equals the sine of theta. So usually when you prove something, you only want to change one side of the equation, and you generally want to change the more complicated side into the simpler side if you can. So the sine of theta plus 60 should be the sine of theta times the times the cosine of 60 plus the cosine of theta times the sine of 60. All of that minus cosine of theta plus 30 would be the cosine of theta times the cosine of 30 plus, so that would be a minus the sine of theta times the sine times the cosine of 30, which looks a little bit weird, but we can get a few equivalent numbers because the cosine of 60 we can get from the unit circles, so the same thing with the sine of 60. Cosine of 60 is 1/2, and the sine of 60 is root 3 over 2. And if we distribute the negative here, we can just start adding a little bit. So the cosine of 60 is 1/2 times the sine of theta plus the sine of 60 is root 3 over 2 times cosine of theta minus cosine of 30 is negative root 3 over 2. Is positive root 3 over 2, but the minus makes it negative, times cosine of theta. And then the sine, cosine, sine. This should have been the sine of 30 degrees. Negative times negative becomes a positive. The sine of 30 is 1/2 times the sine of theta. So again, each of these with an actual number, I just replaced. Cosine of 60 was 1/2. Sine of 60 is root 3 over 2. Cosine of 30 is root 3 over 2. I distributed the minus. And then sine of 30 is 1/2. Minus times negative makes a positive. So half the sine of theta plus half the sine of theta we'll put right next to each other. And we won't do anything with the cosines because the root 3 over 2 of the cosine minus the root 3 over 2 of the cosine cancels each other out. All of this is supposed to equal the sine of theta. A half of something plus a half of something equals the whole thing, so the sine of theta equals itself. Now again, the rules are that you are usually supposed to only change one side of your equation. This next example, I got stuck on a few times, and the only way I could really get myself through it was by changing both sides of the equation. So we're going to approach it that way first. So the secant of theta plus 45 is really the same thing as 1 over the cosine of theta plus 45. The tangent of theta plus 45 plus 1 we can make into the tangent of theta plus the tangent of 45 over 1 minus the tangent of theta times the tangent of 45 plus 1. And all of that equals root 2 times the cosine of theta over cosine of theta plus 45. Because secant is 1 over cosine. Unfortunately, these cosine functions are not taking the same value entirely, so they cannot cancel out. We can also look at the unit circle to see that the tangent of 45 is 1, so we can use that to simplify a little bit. We have the tangent of theta plus 1 over 1 minus the tangent of theta times 1 would be 1 minus the tangent of theta plus 1 is going to equal root 2 times the cosine of theta over the cosine of theta times the cosine of 45 degrees minus the sine of theta over the sine of, times the sine of 45 degrees. I left myself a little bit of space here because that 1 I would actually like to make common denominators with, because I only see one fraction here and two fractions here, or two expressions here. So I'm going to make this into 1 minus the tangent of theta over itself so that we have common denominators. Remember, the tangent of theta is not necessarily a radical, so we don't have to worry about rationalizing it or anything. So the tangent of theta plus 1 plus another 1 would be 2 minus the tangent of theta. You might have seen me hesitate there because the tangent of theta and minus the tangent of theta are going to cancel each other out. So we have 2 over 1 minus the tangent of theta. Cosine of 45 is root 2 over 2. So is the sine of 45. So we have root 2 times cosine of theta over root 2 over 2 times the cosine of theta minus root 2 over 2 times the sine of theta. We can factor out this root 2 over 2 a little bit. That will definitely leave us the cosine of theta minus the sine of theta. We'll still have the cosine of theta at the top. And if we take root 2 and divide it by root 2 over 2, then we get root 2 over 1 times 2 over root 2. So those cancel out. So this is actually 2 times the cosine of theta. The right side is now simplified. Left side, we have 2 over. Still 1 minus the tangent of theta. We need to move a cosine up there somehow. So we'll turn the tangent into sine over cosine. Again, let's take this all the way up here. We can make common denominators down here. So 2 over the cosine of theta over the cosine of theta minus the sine of theta over the cosine of theta is going to equal 2 cos theta over cos theta minus sine theta. 2 over that fraction is really 2 divided by that fraction. And when you divide by a fraction, you flip and multiply. So we really have 2 times the cosine of theta over cosine of theta minus the sine of theta. I didn't really write that neatly because if I wanted to simplify that or take 2 more steps, it would have run me that far. But actually, 2 times all that stuff becomes 2 times the cosine of theta over cosine minus sine, which equals itself. Again, proofs are about the whole process being shown to get that something equals itself. There is no final answer to box, unfortunately. We've got one more example in this set. The cosine of A times the cosine of B minus the sine of A times the sine of B squared plus the sine of A times the cosine of B plus the cosine of A times the sine of B squared equals 1. Luckily, this one's going to be a little bit faster. Cosine, cosine, sine, sine sounds like the cosine of an A and a B either getting added or subtracted. And since that says a minus, but cosine has to be a little bit different, it's A plus B. And the whole thing is getting squared, so the cosine is the part that's getting squared. Plus sine, cosine, cosine, sine is the sine of A and B either getting added or subtracted. Sine keeps the same sign. And that is also getting squared. And if you have the cosine squared of any particular number plus the sine squared of that exact same number, no matter what the number actually is, sine squared plus cosine squared equals 1, and 1 equals itself.